So good afternoon, everyone. Thanks for coming. Today I'm going to talk about how we at Autodesk leverage Splunk as an assurance platform for AWS. And after my half, and then I'm going to hand it over to Praveen, and then he'll talk more specifically about Splunk. So I'm Alan Williams. I'm a principal engineer in the Autodesk Consumer Group. My background is mostly in infrastructure. I've had roles, system engineer, database engineer, architect, the whole gamut, really. I've been using AWS for the past 4 to 5 years, and Splunk for the past 1 year or so. When I'm not working, my hobbies are motorcycling. That's me at my first track day there on the right. And when I'm not doing that, then I'm hanging out with my dogs. So Autodesk, we're the leader in 3D design, engineering, and entertainment software. We're better known for AutoCAD, which we introduced back in 1982. It's still around today, but in reality, we have a portfolio of a little over 100 products. Being part of the consumer group, one of our main goals is to enable the maker movement, and we try to do that by allowing our customers to imagine, design, and create a better world. And by that, I mean you as potential customers and hobbyists. If you have, you're into arts and crafts, woodworking, weekend tinkering, we're trying to provide software that allows you to be able to visualize and realize those dreams. And we have products both on the mobile, web, and desktop platforms. Here I have just a few of the apps that we have on the iOS App Store, as well as those that we have on the Android Play Store. Most of them are free, so after this session, feel free to download them, try them out, and let us know what you think. Also, if there are any students here with us today, or if you know of any students, we recently announced this program that allows any student to be able to download any of our software free of charge. That's students@autodesk.com. So now I'm going to talk about why we decided to go with AWS, or at least our methodology in thinking, does AWS make sense for us or not? So we started that process by a cost analysis. And essentially, we were going from on-premise to AWS. So we had existing infrastructure. We had a number of servers, storage, racks, everything else that goes with your on-premise infrastructure. So we came up with an inventory of what that is, quantities versus specs. And then we pulled up the AWS calculator and did a comparison with what we have versus what similar capacity AWS provides. But part of that cost analysis is not just servers to servers. There's a lot more that makes up your on-premise infrastructure. There's load balancers, there's storage, there's the environmentals, power and cooling, there's rack space, and there's also the support and maintenance contracts that support all this hardware. So all this quickly adds up from a cost perspective. So what we noticed is that if you were to take just your servers and compare them to the EC2 equivalent instances in AWS, we saw like a 35% savings average. But then when we also included our load balancers, storage, and everything else, rack space, it was more like 50%. So it quickly became pretty compelling for us that, at least strictly from an economics perspective, AWS makes sense. We also realized two real outcomes. One, we don't have the scale. We're not small, but we're not at AWS size. So we don't have the ability to compete with AWS on price. There's just no way we can do it. But more importantly, we also can't compete on speed. And by that, I mean, if my internal customer comes to me and says, hey, we need this application deployed and we need the infrastructure for it, traditionally in the past, I would have to involve procurement, the vendor, our ops teams. That entire process takes 4 to 6 weeks. Now in AWS, we can do that in minutes to hours. So that difference in time provides a really compelling and competitive advantage that in this industry, every day counts. So now I'm going to walk you through the various use cases that we leverage AWS for in the Autodesk Consumer Group. Pretty much all our production workloads, all the apps that I talked about in the beginning, they all run on AWS, be it mobile, desktop, or web. Also, all our dev test environments run in AWS. all our net new systems run in AWS. So it's safe to assume that we're all in on AWS. So why did we decide to choose Splunk to enable or manage our AWS adoption? Well, we had Splunk prior to going to AWS. So it was an existing investment that we had. It was familiar technology. Our engineers are comfortable with Splunk. Within our group, Splunk is typically synonymous with logging. Anything that has to be logged, Splunk is the de facto application that we go to. And also, the Splunk app for AWS really easily enables you to manage multiple accounts centrally. And that's something that we have. That's, I won't say a problem, but we are set up in such a way that we do have a lot of AWS accounts. So for us to be able to show or use Splunk to provide assurances for our AWS adoptions, we need to be able to address operations, security, as well as business intelligence. On the operations side, we're collecting data from thousands of endpoints all over the world. That's where Splunk app for AWS really makes that really easy to do centrally. From a security perspective, our security team needs to be able to react quickly to any incidents that happen in our infrastructure. They need to be able to have all the data at hand. And the Splunk app for enterprise security enables that for us. On the business intelligence side, we create custom dashboards that our product teams and executives use on a daily to weekly basis to be able to see how US potential customers or US customers are using our software. Where our software is being downloaded, how many active users we have, what's the ratio of mobile to web, and I'll show you some screenshots of that later as well. So now I'm going to go into a few minutes of screenshots that show how we're using Splunk to enable that AWS adoption. So the first one is the CloudTrail dashboard. And with this dashboard, we can quickly see where or what our error rates are for how our apps are using the AWS APIs. We can also see for each AWS service like SQS, IAM, EC2, how many API calls we're making to them and how that's trending over the past 24 hours. We can also see where in the world those calls are coming from. On the business intelligence side, these are the custom dashboards that we have generated. So here we can see for this particular product, the amount of active users we have, how many new subscribers, how many renewals, mobile versus web usage. We can also see for our internal API calls, what are the latencies for each. And then for some of our products, we have assets that you generate and then upload to the platform. We can see how many are created day over day, hour over hour. On the security front, this is where things get kind of cool and interesting. We can answer questions that we couldn't before. For example, in this particular case, we had a potential breach in an account in a certain time window that we knew the breach happened. We were able to run a query that was able to tell us within that time window what are the events that occurred. And then by getting that list, we can now see if those events were actually malicious or not. But we can go back in time, as far back as we need to be able to do that retroactively or as it's happening right now. Then we're also able to answer questions like, we know this particular host is compromised. We want to know what this host has done in our infrastructure. So we take that IP address and we leverage the CloudTrail data, plug that into Splunk, and here, for example, when we issue that query, we can see that this particular instance was used to describe our other infrastructure. So based on that information, we could then see, okay, was that a threat or was that not a threat? But this is all vital data that our security team needs to be able to see and react on a fairly quick basis. Also, this particular use case is fairly common where you have an IAM key, and since I mentioned we have a number of AWS accounts, you have no way of knowing which account it's for and what are the permissions behind it. With CloudTrail and Splunk, you can plug in that IAM key, and it will tell you what account that IAM key was issued from, and also what that IAM key was used for. In this case, we can see that it was used to create an SQS queue, and it was used to describe health checks for ELB and EC2. And then lastly, We can also visualize where our employees are accessing the AWS console for. So in this case, we can see authorized versus unauthorized access on a global basis to the AWS console for all our accounts. Now I'm going to spend some time talking about how we operationalize running Splunk in AWS. So you have Splunk, you want to move it to AWS, this is how. For us to be able to run Splunk in AWS, we needed to be able to achieve at least 3 tenets. We had to be able to we needed automation, we needed scalability, and we needed performance. For automation, we developed and outsourced 2 GitHub repositories. One that contains a CloudFormation template. That CloudFormation template builds the base infrastructure for your Splunk cluster. So it builds the servers, it provisions the storage, the ELBs, load balancers, the VPCs as well. And I'll show you in the next slide more detail what that does. And then once that base infrastructure is provisioned, then the other repository contains the Ansible playbook. That Ansible playbook downloads Splunk, installs Splunk, configures Splunk, and then configures each component of the Splunk cluster. So the search heads, the peer nodes, the supporting cluster master, license master, each one, as well as security, each one that playbook configures for you. So basically, you can run Splunk, or you can run a brand new Splunk deployment in under 20 minutes without really needing to know how to install Splunk itself. From a scalability perspective, we need to be able to add and remove nodes quickly. So for example, search heads. A user could potentially run an ad hoc query that consumes all the CPU utilization on 1, maybe even 2 search heads. That then will yield a negative user experience to another user. By leveraging auto-scaling groups, we can set up policies that say once CPU utilization hits 80%, provision 1 or 2 more nodes. And then when average CPU goes back down, so let's say 40%, then deprovision nodes. So that makes the system very resilient, and we don't need to have somebody there that's constantly monitoring and reacting. It basically handles itself. Then I mentioned search head pooling, but search head pooling is a feature that we leverage today for scalability. That basically allows you to have a shared NFS share, or, data store that can be accessed by multiple search heads. In the latest version of Splunk, Splunk 6.2, they've deprecated search head pooling, so it's no longer needed, and that's something that we're going to be doing pretty soon. So I just mentioned it for historical purposes. And then performance. Performance is key, right? If you have your Splunk cluster and it takes minutes to run your searches, your users are not going to be happy. So you want to be as fast as possible. And what we found in our tests is that the C3 instance family is a good fit for search heads because they tend to be very CPU intensive. And then for indexers, we have a few more options. So depending on the size of the cluster that we're building, if it's a dev test cluster that we're just like testing a new feature or testing a new data source, we want a small data set. So for those, we typically go with C3 EC2 instances plus EBS. But for our larger production clusters, that's where we really leverage I2 instances with a local ephemeral storage. HS1 instances are also a good option as well. And then to maximize your IOPS, you want to RAID 0 all your disk volumes. So this is the typical infrastructure, the Splunk infrastructure that we build. And the CloudFormation template and Ansible playbooks, this is essentially what they will build for you. So at the very top, we leverage Direct Connect to bridge our corporate network to the VPC where Splunk is running. We have our ELB at the very top, and then that talks to a fleet of search heads, which then talks to a fleet of peer nodes, and then we have the supporting infrastructure on the side. And as you can see, everything is in an auto-scaling group. So now I'm going to talk about how we use CloudTrail plus Splunk together, what our typical configuration is, to be able to manage a large number of accounts centrally. So for this example, account A and account B, it's, let's take that to be one product versus another product. But then we also have a third account called the core services account. And that account typically hosts any infrastructure that's common across the vast majority of our accounts, so like DNS, monitoring, Splunk. So we enable CloudTrail in each of the linked accounts, and we configure CloudTrail to send its events to the central S3 bucket in the core services account. And now all this can be done either via the AWS CLI or the AWS console. CloudTrail also sends its events via an SNS notification topic that then sends its messages to a central SQS queue in the core services account. Splunk then pulls SQS queue, and the messages in that SQS queue contain the URL of where that event is located in S3. So Splunk just has to look at that message, and it knows where in S3 to pull in the logs. We've found this deployment to be really simple to configure. Because all the components are very decoupled, it's also very scalable. And it enables our need to have one central location for all that data. So in summary, I talked about how AWS and Splunk is really, for us, an ideal couple, how we leverage CloudTrail and Splunk in a scalable configuration that works very well across hundreds of accounts, and additionally, how we use our various use cases for Splunk that are leveraged by our operations, security, and business teams. So these are the two URLs for the GitHub repos where you can download the CloudFormation template, as well as the Ansible playbook to be able to build that Splunk infrastructure that I showed a few minutes ago. When you run all these, you can essentially have that environment in less than 15 minutes, or around 15 minutes. And now I'll hand it over to Praveen.
Thank you, Alan. I've got to tell you, I love presenting with Alan. These guys make great use of our software across so many different use cases, and he shows just how easy it is to deploy Splunk at scale on AWS. They have deployments that are over 1 terabyte of data per day, and he's automated the whole thing to get it up and running in the snap of a finger. And on top of that, all of the work he's done with CloudFormation and Ansible, he open sources all of that and shares it with all of you, so you guys don't have to do any of that work. So really, thank you, Alan, for everything you've done, and I love presenting with him. So, yes, absolutely. So I'm going to start. You might have all gotten a flavor of Splunk at the keynote today when our CEO spoke. I'm going to take it 1 or 2 levels deeper as to what we do and how customers use us, especially on AWS. So just quick stuff about us. We're about a 10-year-old company. We're 1,000 people now. The way in which Splunk actually grew was by giving away our software for free. It was one of the very first companies with this idea of the consumerization of enterprise software, where it was very user-centric. We really believed, let's give the software for free, let people use it. If they like it, they'll buy it. And that's how we really got to our growth, through our free download model. And now we have a free online sandbox, which is hosted in AWS, that lets you instantly get access to Splunk. You have essentially a 14-day free trial to the full feature set of the software. Just another thing to mention here, 8,000 customers all around the world. But the really important thing is the amount of overlap we have with AWS customers. So like AWS customers speaking at this conference, in addition to Autodesk here, Adobe is speaking here, Nike is speaking here, NASA, Intuit are speaking here. All of these customers, Coca-Cola, all of them are Splunk customers, right? And all of them are using Splunk for monitoring and helping them move applications to AWS. Even in Andy's keynote on Tuesday, Major League Baseball is a Splunk customer. So every baseball game that they stream online, including the World Series that they did for the first time, all the operational monitoring for that is done by Splunk. Intuit, when they move Quicken, TurboTax, Mint, all to AWS, all the security and operational monitoring is done by Splunk. So I'm going to get into why these companies are using Splunk and kind of what we're all about. So first thing is, what we're about is machine data. Right, so machine data basically is a set of all the data that powers your business. So that's server data, application data, network data, email data, mobile data, whatever it is. It also includes data that's generated from your AWS environment, like CloudTrail and config, which is a service that they announced just yesterday. So what CloudTrail does, of course, is give you access to your security-related user activity in your AWS account. What config does is kind of a sister service to that. It gives you visibility into the resource configuration in your AWS account. So we provide solutions that let you take all this data, visualize it, analyze it to keep your security posture strong. So we're about machine data, but the thing with all this data is it all comes in different formats. It all comes in different file sizes. None of it looks the same. So the challenge is, how do you make sense of all this machine data? So what does machine data look like? So at the highest level, it essentially looks like a bunch of gobbledygook, right? You look at it, and it wouldn't make sense to anyone just at the naked human eye, right? So enter Splunk. Where we come in is start to put the pieces of the puzzle together. Right? So we'll say this piece is the order ID, this piece is the customer ID, this piece represents another piece of information. Right? We'll take this gobbledygook and start to say, okay, this is what each of the different pieces of the puzzles is. But of course, that's just the beginning. Right? The real magic of Splunk is when you can put the pieces of the puzzle together and you can tell a story around it. So you look in this example, you can see a story of a customer who tried to place an order, and then there was an error in the middleware layer. It timed out. The customer then called up to the customer IVR, Customer Care Center, spent too much time waiting on hold, so they put out a tweet saying, this service sucks, it doesn't work, I gave up on the service because nobody picked up the phone. Right? So here's one story that's hidden in all of the machine data that Splunk surfaces and brings to life. So let's extrapolate from here. What are all the different stories that you can tell from your machine data? And so we see a couple of set of core use cases that customers use Splunk for across managing applications, IT operations, and security. And we also see a set of emerging use cases around digital intelligence, business analytics, industrial data. And I'll map this back to what Alan said and how Autodesk is using Splunk. You heard them using Splunk for IT operations and security. They're collecting data from thousands of endpoints around the world and managing that. They're using the CloudTrail app to monitor security of their AWS environment. They're also doing business analytics, getting usage of how are their customers using their products, right? So they're actually also not just in the core use cases, but also on the emerging use cases. They're actually analyzing how are customers using our products and services, how can we tweak them to make it better? And it's not just engineers and IT folks using it. They have business executives who have everyday visibility into dashboards for Splunk because they want to know exactly what the status is of how customers are utilizing their products. So really a full set of solutions of how customers get what we call operational intelligence, which is a full knowledge of everything that's going on in their environment and their customer behavior from their machine data. So what the picture basically looks like is we take in any data from any location. So the data can come from an environment you have on-prem, it can come from something you have in the private cloud, it can come from something in AWS or any other public cloud. We suck in all of that data, whether it's from servers, security, whatever it is, into our core solution. So Splunk Enterprise is our software offering. You can deploy that anywhere, whether it's on-prem or in AWS, and that's what Autodesk does. They deploy Splunk Enterprise on AWS. And we also have Splunk Cloud, which is our software as a service offering, which is where we do all the deployment of Splunk for you. You guys just consume it as a service, just like Salesforce.com, for example. So we suck in all your data, and then we enable you to do things like search on your data, monitor the data, alert on the data, visualize it. We have a full developer platform, so you can build applications on top of the data as well. So what are the solutions we have for customers in the AWS ecosystem? So first we have the software as a service offerings, Splunk Cloud, which is the full feature set of our software as a cloud service, all hosted on AWS. We also have the Splunk Online Sandbox, which is our free trial in the cloud where you can just get on, and in 10 seconds, you'll have a fully provisioned Splunk environment at your fingertips. We've got the BYOL model, the bring your own license model that Alan and Autodesk uses of self-managed software on AWS, which of Splunk Enterprise, and also Hunk. Hunk is our big data analytics software, which basically lets you analyze data in Hadoop and other NoSQL stores. EMR and S3 is what that means in the AWS world. On the integration side, we have AMIs up on the marketplace, so you can get up and running from the marketplace. We also just 1 or 2 weeks ago announced this integration between Hunk and EMR, where you actually can now, while you're provisioning Elastic MapReduce nodes, from the console itself, you can get a drop-down and you can add Hunk for visualization. The idea behind Hunk is that data in Hadoop is often very difficult to analyze and visualize, and whether that's in Hadoop or in S3 or anywhere else. And so we provide all the user interface and analytics of Splunk and apply that to that data that's in S3 or EMR or Hadoop. So this is available now for 75 cents an hour. So really easily you can just get up and for $1 or $2 you can get a few hours and try to start getting value from all the data you have at rest in S3 or in EMR in the AWS world. We also have this app for AWS which sucks in all of this data streams from AWS itself, like CloudTrail, CloudWatch, config, billing as well. So, and that's the application that Alan spoke about that they're using. So let me dive a little bit deeper into Splunk Cloud, which is our software as a service offering. It's about 1 year old now, maybe 13, 14 months. So there are three fundamental tenets of our Splunk Cloud SaaS offering. First, essentially it's designed based on our customer feedback, and customers told us they wanted these three things. The first is a full-featured SaaS offering. The second is something that's enterprise ready, and the third is something that's easy to use. So let me go through each of these in a little bit more detail. So for full-featured, our SaaS offering has a full feature of our core software set, Splunk Enterprise. It essentially is the same feature set, same functionality delivered as a cloud service. It also includes access to the full range of applications that Splunk offers. So apps are basically pre-built dashboards and reports and visualizations that actually give you a very easy way to get very quick insights into your data. So all that application support comes with Splunk Cloud as well. We also have a hybrid deployment architecture, and this is actually kind of a very interesting and unique thing to Splunk, which is that you can deploy Splunk Cloud, which is our SaaS offering, and consume it as a service. And you can also deploy Splunk Enterprise yourself, right, in AWS or anywhere else. And then normally you might think these are two separate deployments, right? One is a software deployment, one is a SaaS deployment. But what we see from our customers is the real value of machine data analytics is when you have a centralized view into all of your data. So we're actually the only company that provides what we call hybrid search, which is that you have single pane of glass visibility across everything. So what it means to you guys is, if you have certain data sets that you think, I have to manage this myself, right? I don't want to send this to a third party. You can manage it yourself through Splunk Enterprise. If you have other data sets where you think, it'd be great to just have this as a service from Splunk, you can use Splunk Cloud, and you can still have single pane of glass visibility across both. So it lets you pick and choose, when you want to deploy software, when you want to consume SaaS, but you still get the same benefits of centralized visibility. That's a very cool and unique feature that we have. So let's talk about enterprise ready now. So, like I said, we work with companies like, Coca-Cola, Adobe, Autodesk, FINRA, Nike. FINRA and Nike are the bigger ones on our cloud service, and we know that these guys need enterprise-ready uptime, as does everyone in this room, as does every company of every size. So we've really architected it for uptime and performance, and we actually back it up with the 100% uptime SLA. So if we offer anything other than 100%, you actually would get money back. And I'll talk a little bit about what we do to actually build for 100% uptime in 1 second. We also have plans that range from 5 gigs to 5 terabytes. And we also have robust security policies across our security attestations like SOC 2, as well as the fact that we provision dedicated environments for every customer, so there's no data commingling. So I want to jump back to this idea of 100% uptime, because when we talk to customers about this, most customers are usually thrilled to hear our commitment to uptime, but a lot of customers wonder, how in the world does Splunk, build for 100% uptime? Nobody has 100% uptime. So there's a couple of things we do. The first is we, of course, architect across multiple AWS AZs. So in the event there's any problem with one AZ, it seamlessly goes over to another. And that's a huge thing as well. We incorporate HA, or high availability, across our indexers and search heads. So again, if there's any issue across any one of our systems, we seamlessly fail over to another. We also provision dedicated cloud environments for every customer, so we don't suffer from system-wide outages to our entire service. The last thing that's important is that we monitor our cloud service using our own software, Splunk Enterprise. So if you remember from our use case slide, one of the core use cases of our software is application and service uptime and performance. So we essentially, quote unquote, eat our own dog food, and that we monitor our entire Splunk Cloud service using our own Splunk software. So that's everything is monitored in real time. We have 100% visibility into everything going on in our service. So all of these things contribute to how we build for 100% uptime and are confident in offering that SLA. So to jump to easy, what do we do to make it easy? The service starts at $675 per month. That is billed annually. We just did a 33% price reduction a few months back. We basically gained operational efficiencies running our service, and somewhat a la AWS, we've shared those efficiencies with you. So we announced a 32% reduction across the board for Splunk Cloud. We did that in August. We have the sandbox, which lets you get immediate access to our software, and just also immediate deployment. There's no waiting for infrastructure, there's no waiting for hardware. You have your Splunk deployment up and running at the snap of a finger. Net, what we do with Splunk Cloud is all the hardware setup, all the storage, scaling, and monitoring. What you do is forward your data, just search, monitor, and start getting the value. So that's our Splunk Cloud offering. So just to wrap it up, to kind of echo to what our CEO said in the keynote today, we see enterprises of all sizes moving workloads to AWS. And if you want to gain visibility into those applications, and if you want to move that with confidence, that's what Splunk is all about. And that's why so many AWS customers are using Splunk with their AWS deployment for visibility, real-time monitoring, and to get confidence as they migrate towards AWS. So it's a really great partnership that we have. We've got great customers using the software on AWS as well. So thank you for your time and listening today. I think we have some time left to take questions. So I'd invite Alan back on stage. We have our product manager for Splunk Cloud as well. Invite him to join us as well. And we'll open it up for questions. Yeah, absolutely.
I was just curious about your indexing volume and like how many indexers, like the I2 indexers, how many gigabytes or terabytes you're indexing with those?
So we run multiple clusters depending on the Autodesk division. The one that I showed is a fleet of 6 I2 4XL indexers, and they're ingesting about a little over 500 gigs per day.
Yep.
You mentioned about multiple accounts, database accounts of yours. You can use one Splunk account to migrate multiple databases.
Right.
But in your diagram, you mentioned you have a core account. You are pushing all the data using cloud to the centralized service for the S3 as well as for the queue.
Right.
So that means Splunk is just monitoring the primary, it's looking into the queue and into the S3 to get the data from only one place. It's not looking into each of your accounts.
Exactly, and that's the advantage of setting it up that way.
So I just want to understand clearly, right? Because it's actually monitoring only one account. It's not actually monitoring all.
Correct, because all the linked accounts send all their data to the core services account. So that means Splunk just has one SQS queue to monitor, and hence one S3 bucket to pull from.
Is it other way possible that if you do not want to, if you do not have a centralized account, is it possible for Splunk to give multiple S3?
Oh, yeah. Yeah, so in the Splunk app, when you configure the modular input, there is basically you create one entry per SQS queue that it's pulling from. So if you want to have it logged to each individual linked account, you can definitely do that. It's more overhead, but it can technically you can do it, for sure.
One more question for you. Why you did multiple AWS accounts for each of your product or application you have separate accounts?
Yeah, so why we have so many accounts, that's a whole long discussion, but essentially, yeah, every product has its own account. Yeah.
I have one question. The logging format, do you have like a standard schema kind of for the logging format?
We don't, so that's actually one of the beauty of Splunk is that you don't have to have a standard format. You can, but it's pretty adaptable that no matter what the format is, typically as long as there's a timestamp and every line corresponds to a single event, then it's really easy to make Splunk understand it.
Yeah.
Another one.
Yeah.
I noticed on the Splunk app up there for AWS that you weren't using CloudWatch to do like the system monitoring level stuff. Are you using like the Unix app for that or some other sort of like CPU measurements?
For the Splunk cluster itself?
Well, I mean like for this other instances that you have out there, like what are you using like for like that system CPU level?
Yeah, so for monitoring, we use multiple tools. We use Nagios. We do use CloudWatch in for certain apps. Actually, it's mainly Nagios and CloudWatch for the AWS apps. But the CloudFormation template actually builds the CloudWatch metrics and alarms that will monitor the actual Splunk environment itself. That's part of what it does as well.
Cool. We have some more time, so feel free if you guys have more. Yeah.
Are you sending out Splunk from
This Splunk deployment doesn't pull in syslog data. It's all, we have universal forwarders in all the instances, and that's what's collecting the data. And that's typically application logs or even OS type logs. So yeah, we're not leveraging syslog. We do on the corporate IT side, they do leverage syslog for the storage devices and the network appliances. They do send their syslog data into Splunk.
Do you utilize alerting from Splunk itself, or do you do that all through Navigator?
Yes, we do. I think I had a slide, one of the screenshots that kind of showed that. But whenever an IAM user is created, or whenever a security group is created that has a rule of 000/0, there is a Splunk alert that generates in real time, and it will send us an email and also create a PagerDuty incident to let us know that that's happened.
Do you use pulse event correlation within your environment, or is that something that you would use Splunk for? So is it querying and alerting based on the single event from a single source, or is it more complex correlation?
Well, in some cases, we do leverage lookups that come from relational databases or static lookups. So yeah, there are some use cases, mostly on the business intelligence use cases, where they do leverage from multiple data sources.
Anything else? Great. Well, I love it. All the questions for Alan. So he's always the star of the show. All right. Well, thanks, everyone. I think they
guys.
want us to end with this slide. So if you have feedback, please do give it. We'd love to hear from you guys. And I know Alan would love to hear your comments on his
Yeah, definitely. Let us know.
GitHub and all that as well. Thank you.
Thank you.